It's not terrible, better than the competition, but it's still not an L.
Well, it's cheaper than an L. That's what you say.
Yeah. Well, I know, but you can't see, some of the people have been saying that, even some of the people in the training academy have said, well, it's a cheap helicopter, what do you expect for $1 million? And that's not great.
No, I spent $1 million. I don't want that.
I know how many $1 million do you have in your back pocket?
Yeah.
Not good. Not good. So,
at least you guys got it out there where we're making money.
Well, we got to
get to 5 there.
Oh, yeah.
That's more than a year away.
That's a pretty steep hill right now.
Yeah, it is.
It's going to be interesting, that's for sure.
Terrible.
Ladies and gentlemen, we will start for the last session of the day. Please go back to your seats. Hi. Nice to meet you.
Nice to meet you too.
I'm from EASA. We had the exchange of few emails.
Yes.
I think.
Yes, we did. Yep.
Some safety experts. Nice to have you with us.
Yep.
So just maybe wait a few minutes before going.
Okay.
Please take your seats. We will start again. Ladies and gentlemen, if you don't want to miss the reception at the end of the symposium, we have to start now. We have 3 presentations. Yes, so last session of the day, we are back in the Airworthiness session with 3 presentations. I'm now welcoming on stage John Strasburger from the FAA. Please.
Please, have a seat.
John will present on the subject of advanced flight control automation. Thank you.
Well, thank you. Well, good afternoon. Again, my name is John Strasburger. I'm the Emerging Technologies Program Manager in the Rotorcraft Standards Branch. And I have a really interesting topic for you this afternoon on the use of artificial intelligence to automate stuff in the cockpit. I had the opportunity to attend the Uber Elevate conference in Dallas this past April. And there's some really exciting, innovative concepts that are being developed by industry to support the urban mobility aircraft. And one of the key technology enablers for this next generation of aircraft is machine learning. Some companies plan on using machine learning to automate different aircraft flight functions. So what we really needed to do is start the discussion on how we're going to address machine learning for multi-rotor rotorcraft, as well as power lift aircraft that are coming in the near future. So the objective of my presentation today is to jumpstart that dialogue with industry and the cert authorities. So in this presentation, I'll briefly introduce some machine learning terminology, discuss 4 different certification challenges that are focused on the development assurance aspects only. I'm not going to talk about cybersecurity because there's aspects of that. There's also aspects of human factors and the interface with air traffic control. I'm not going to talk about that, but I'm going to focus on development assurance challenges. Look at 2 different development assurance considerations that we have to factor into our designs. And look at some potential approaches to gain trust in machine learning. Then talk about research that the FAA has sponsored in the past and have research reports on, and research that we're going to sponsor in the future. And then talk about 2 other related activities. So machine learning algorithms is an algorithm that are very powerful pattern recognizers and can be trained to learn very complex operations like landing an aircraft without being explicitly programmed. However, machine learning, even though they're not explicitly programmed during this normal software development process, have to go through a training process. And that training process, depending on the complexity of the machine learning function, could require thousands of sets of training data, and this will become more evident later in my presentation. Now, deep learning is a machine learning method that uses neural networks with multiple hidden layers between the input and the output layer, and I'll show a neural network on the next slide. And the reason for this is that these additional layers increase the network's learning capacity. Neural networks are loosely patterned on the neurons in the brain and the interconnections in the human brain, in which neurons fire depending on encountering a sufficient stimulus. They can be used to model very complex relationships between inputs and outputs or find patterns in data. Here's a picture of a very simple neural network. The inputs are X1 and X2. The output is Y. On the left, we have the input layer of neurons, F1, F2, and F3. Then we have a hidden layer of neurons, F4 and F5, and then we have the output layer, which is neuron F6. This is a very, very simple neural network. In reality, some of the networks can have over 1 million neurons, can have multiple hidden layers, not just a single one, so they can really model very complex functions. The other term I want to talk about is deterministic behavior. From my simplistic perspective, given a specific input and a state, you know exactly what the output is going to be. And that's going to be important later on. The National Highway Traffic Safety Administration, in their recent policy statement for autonomous cars, defined 6 different levels of automation. I have taken those levels and adapted them for aircraft. This is a first cut at it. It's just kind of notional, but I think it's important to understand the different levels of automation. So at level 0, you have no automation whatsoever. The human has full-time performance of all dynamic aspects of the flying task. When we move up to level 1, the automation assists with some flying modes. On the automotive side, they look at 2 different controls: lateral control and longitudinal control. Lateral control being steering and longitudinal control being the throttle or braking. And for this first level, the automotive industry just looks at either lateral or longitudinal control, like an adaptive cruise control system. But level 1, the human pilot and the system would be responsible for, would share the responsibility for aviation, the navigation, and the communication. The human pilot is still responsible for monitoring the automatic flying mode performance, and the human pilot, should the automation fail, would be responsible for taking over command. As we move up to level 2, this is where we add additional flying modes. In the case of an aircraft, it could be a 2-axis or 3-axis autopilot. The human pilot and the system are still share the responsibilities to aviate, navigate, and communicate. And the human pilot is still responsible for monitoring the flight performance of the automation. When we get up into level 3, things get a little bit more interesting. At level 3, now what happens is the human pilot is no longer responsible for monitoring the automation. And as we work up all the way to level 5, the human pilot's completely out of the picture. Human pilot the system is responsible for full automation without a pilot backup. So I can talk a little bit about some background information. Civil aircraft, rotorcraft already have very sophisticated level 2 autopilots, including search and rescue functionality. However, they are monitored by the pilot. They were developed using a rigorous development assurance processes for software DO-178, for airborne electronic hardware DO-254, and for systems aspects 4754A. They have deterministic behavior. Now I'm going to tie all this stuff to the rule. 27.1309 and 29.1309 both state that the equipment and system and installations must be designed and installed to ensure they perform their intended function under all foreseeable conditions. This is where we get to the first big challenge as I see it. As the level of autonomy is increased, how does one show that the autonomous flight controls perform their intended function under all foreseeable operating conditions? This is a big challenge because there is an infinite number of operating conditions that the machine learning may have to handle. Different weather conditions, different operational scenarios, emergency contingencies, failures of the system, so they have to handle all that. And if machine learning is tied to sensors, whether it be a LiDAR, a radar, or a high definition camera, they have to handle the different environmental conditions that sensor has to work in, to include rain, fog, snow, dust, lighting, all of which can affect the performance of the machine learning. Then the other thing you have to worry about is also the sensor imperfections. If there's a scratch on one of the lenses for like one of the high definition cameras, that could also affect the performance of the machine learning. Challenge 2 is for level 3 and above, an autonomous function will not be monitored by the pilot, unlike today's autopilots. Challenge 3, which I think is probably the most significant one in my perspective, because I'm going to have to do something about it, because I'm going to be responsible for developing the guidance, is we don't have existing guidance for machine learning today. The algorithms, for the most part, are non-deterministic. They don't follow the 4754A system V model, so the expectation for the left side of the system, I don't know if you're all familiar with the system V model in 4754. We're on the left side, you have the requirements, and on the right side, you do your verification. Start from the top, where you'd have your aircraft level requirements, your system level requirements, and you get down to your item level requirements, and over on the other side is where you do verification of each one of those types of requirements. So the problem is when you use a machine learning that you're not going to have a specification for your item level. Okay, so that's the lowest level. What you're going to have is a training set, and you're not going to be able to show that from that training set, I can go in and look at the actual neural net and the weights on that neural net to determine whether it satisfies those requirements. You just can't do that. So so what that means is that we can't satisfy all the assurance process objectives today in 4754, DO-254, and 178. That's a big challenge. The fourth challenge is if we allow these algorithms to continue to learn after we do the development. So this is during the operation of the machine learning function. I had the opportunity to attend an autonomous vehicle symposium out in San Francisco this past July, and I was probably 4 or 5 presenters all clearly stated, this is on the automotive side, that's really important that you independently verify the output of these algorithms. And how can you do that if this thing continues to learn during operation? The other problem is if you do allow learning to continue, they could diverge from an acceptable behavior because, number one, you're not monitoring what the output is. And the other thing that could happen is you could have different behavior for each aircraft. So if you have two different aircraft operating in different operational environments, different environmental environments, they can diverge. So, which would make, if you ever had a continuing operational safety issue, it may make the analysis very difficult. get a show of hands. How many of you use Siri, Alexa, or Cortana? Do any of you use them? Does it always get it right when you speak your text? Does it translate that text always right to the command that you're trying to accomplish? I know I use it all the time, and sometimes when I text my wife, I use Siri, and sometimes she gets some really weird text from me, and then she's getting used to it now. But first couple times I did it, she had some issues with it. So all three of those applications use deep learning, machine learning, and they do make mistakes. In a technical report that I read, which is entitled Analysis of ISO 262 Using Machine Learning Safety in Automotive Software, the authors state that an ML model typically does not operate perfectly and exhibits some error rate. Thus, correctness of an ML component, even with respect to test data, is seldom achieved, and it must be assumed that it will periodically fail. So when we are using machine learning, we have to take the assumption. I think it would be a hard sell for me for an applicant to come and say, well, this thing is going to be error-free. So you have to take that assumption in your design, in your development, that you may need some type of mitigation for those errors. The other big thing is you could imagine how difficult it would be to train one of these algorithms because of the operational differences, the environment, all that has to be taken into consideration. So the training, there's a good chance the training could be incomplete. Now, one of the things in 4754A is the assumption that the requirements are validated. By validated, they are correct and complete. So it would be very difficult to demonstrate that, through this training set, that training set is captures the complete set of requirements. So how can we gain some trust in machine learning? I'm a proponent of doing things in phases. Let's crawl before we walk and walk before we run. And I think that's the way the automotive industry as well. Is if you take a look at, they're working their ways from level 1 to level 2 to level 3. And I think that makes all the sense in the world. So we need a safe and methodical reduction in crew workload to the point where automation can be assured to be safe and trustworthy to replace the human in the different phases of flight. The other thing that I've seen in the automotive industry, as well as for UASs right now, is the use of a runtime assurance architecture. This is basically instead of having the pilot monitor the performance of the machine learning algorithm, use the system to do that. Over on the left, we have sensor data. It's pre-processed by this RTA input manager. And this RTA input manager distributes that input data to the complex function, which is an untrusted system with the machine learning, and to a trusted safety monitor which has a recovery maneuver. If the abnormal behavior is detected by the monitor, it will invoke a recovery function. So that's the idea behind a runtime assurance architecture. It's really a safety net. The ASTM F38 committee, which recently created an industry document entitled Practices for Methods to Safely Bound Behavior on Manned Aircraft Systems Containing Complex System Functionality. And that employs a runtime architecture because they feel that these systems are so complex that we need some way of monitoring when they have some abnormal behavior and invoke the correct action to avoid a safety issue. Now, another way is to get extensive usage of the machine learning. I do see in the future that modeling and simulation will have a huge role in helping us gain some trust. A simulation can run 24 hours a day and can look at many different scenarios, but it's not a replacement for real-world operational use of it or flight test. One of the advantages the automotive industry has is, at least in the U.S., that they have an exemption process which allows them to introduce 2,500 cars a year when they're trying out a new technology. So if you take 2,500 cars, multiply it by 12,000 miles, that gives you 30 million miles of use in 1 year. So that really helps them out. We don't have that. We can't do that, and I don't think with helicopters. The other thing is, I think it's a really good idea is to have an enhanced data recording to allow reconstructions of circumstances that result in anomalous behavior. So if we have a machine learning algorithm and we have a runtime assurance architecture with the safety monitor, every time that monitor trips, it would be a good idea to collect all the data that led up to that, that tripping of that safety monitor. Because then you could go back and look at what is the root cause? Is there an issue with my training data? Is there an issue with my verification approach? So I'm going to kind of change gears now. FAA has sponsored research. This research, the first one is the verification of adaptive systems. This was completed about 2 years ago. This was performed by NASA and Honeywell. The report is available at this URL, so you can download that report right as shown on the slide. The FAA has now proposed some additional research. We go through a research requirements process once a year, and we're just in the process of doing that right now. We have proposed some additional research and looking at strategies for adoption of certification of intelligent systems and looking also at the human factors aspects of machine learning. How many of you are familiar with the Aerospace Vehicle Systems Institute, AVSI? Is anybody familiar with it at all? Nobody? AVSI is a research consortium. It's managed out of Texas A&M and it's administered out of Texas A&M. I've been involved in research for the last 9 or 10 years and have been involved in multiple AVSI projects. These projects involved multiple companies in the US and in Europe. They could involve the Department of Defense on the US side. They've involved NASA and they've involved the FAA. And it's a great way to get collaborative research done by multiple entities so you don't have a biased research output. They are going to start a machine learning project this in calendar year of 2018. Dave Redman is the manager out of Texas A&M. We have multiple companies that are very interested in working on this project, to include myself. And we're looking at two things: investigating different verification methods for machine learning, and to really focus in on the safety net aspects, the runtime assurance. CARP, what a name. That's a fish in the United States. It stands for the Certification Authority's Rotorcraft products. CARP is one of 5 groups formed under the certification management team. Certification management team is the senior directors from the FAA, EASA, Transport Canada, and ANAC. They have recently chartered a Rotorcraft Advanced Flight Control working group, working subgroup. The objective of this group is to develop harmonized revisions to the Advanced Flight Control handbooks and a revision to miscellaneous guidance, section 17 in the 2 mega ACs. The team is being currently formed. Our advanced flight control expert is FA Olgan Lai. The other thing is the FAA is looking at having an automation workshop in Washington, D.C. sometime this summer of 2018. And we were looking at machine learning, the human factors aspects, maybe cybersecurity, across the board of what the real challenges are to safely introduce a big increase in flight automation. So in summary, I see that there is some significant hurdles to safely introduce machine learning. I think if we take this slowly at least first and develop a good understanding of what the real certification challenges are, I think is the right approach. One way for us to gain knowledge is through research. And if you are aware of any other research that I may not be aware of, please let me know. Because I'm trying to get us up to speed on this as best I can. The other thing is I think we really need to leverage what's going on in the automotive industry. They have a lot of invested into machine learning and these driverless cars. There's some standards work being done under SAE. They're looking at verification approaches for machine learning under an SAE project. And I think it'd be to everybody's best interest to exploit what they've done so far. Well, that's it. I'll be here to answer questions later on.
Thank you, John. Now I'm calling Olivier Tribou from EASA. He will present a very practical and easy to use tool to facilitate the sharing and exchange of information in the frame of certification projects.
Session 2 und das ist Part 2. Nee, du bist Awareness, so bleibst du. Das ist jetzt die zweite. Das war, ne?
Ja.
Und hier ist der Klicker.
All right. Good afternoon, everyone. My name is Olivier Tribou, as mentioned. I'm the CEPIAC project manager. And what is CEPIAC? So CEPIAC stands for Shared Electronic Platform for Initial Airworthiness Certification. It's a very long name for actually a very simple tool. And as mentioned again, it's very practical, very down to earth. What we are trying to achieve with CEPIAC is to ease our daily task. And when I say our daily task, is really our daily task, meaning yours and ours. The way we work today, basically, is to send emails. So when you want to send us an application, you send us an email. When then you want to send your certification program, you will send us an email. Then we receive this email, and usually we make it circulated among the team at EASA. And we gather all the comments through emails. Then the PCM will usually collect all these comments and make a summary out of it, and it will send you an email to tell you what is our position. And then again and again for every certification document and every discussion that we have. The point of CEPIAC is to get rid of this way of working and having one central place, one central platform that everybody can access so that everybody can see the same documents, the comments, and so on and so forth. So getting basically rid of emails. This is really our target. So I have a couple of slides I will show you. So CEPIAC, as I said, is basically a new way to exchange by having one central platform instead of an email avalanche. And it's part of a broader EASA initiative named Coral, which has been triggered by the industry. And the point is to ensure a digital continuity through what they call end-to-end workflow, so from application to certificate. Now, CEPIAC basically bring this visibility and clarity on what is the status of a given document, what is the latest version of a given document, and who is doing what. Now, there is a bit of technical data So it's a cloud-based platform, so it means it's not hosted at EASA. It's a SharePoint 2016, so if you know what is SharePoint, you will feel at home. And the revolution, so to speak, is that it's accessible for EASA, for you, but also for the NAAs and even for third country authorities. So when we do validation in the US, in Canada, or anywhere else, we can open the platform for these people as well. Now, a usual question that we get is the security. So it's a cloud, yes, but it's not like when you use Google or Amazon or Dropbox or that kind of stuff. It's the private cloud. So it's a community cloud in this case, meaning that it's only for European agencies. And it's compliant with the ISO regulation on these IT cloud systems. The cloud is hosted in Germany, and it's duplicated as well in another location in Germany. And it has been audited by the European Agency for Infrastructure Security. A question that we get quite often is, okay, who can see what actually? Because, okay, it's nice if you open it to everyone, but we don't want everyone to see. So, as an applicant, obviously, you see only your own projects. EASA, we see everything. For NAAs, they see only the projects where they are allocated. And for the third country authority, it's even more restricted because they see only the projects where they are involved and only the documents we want them to see. Now, to access the platform, basically, you need an account. And who needs an account is anyone having interaction with EASA, so with our PCMs or with our experts. So to do this, you can send an email to this email address, cpiac-help, and you can request the creation of an account. We will create a so-called admin user, and this user is then able to create further users for your company. Now comes the training. So it's a new tool. Obviously, you need to get used to it. You need to get some training. When it comes to EASA users, it's easy because we have everybody in the same building, basically. But for you guys, it's slightly more complicated because we cannot come to all of you and organize training. So what we do is that we have put some training materials on the platform. You can use that. So everyone having an account can have access to this. And you can use these PowerPoints, PDFs, and so on to train your staff. We will also organize a number of workshops and what we call the roadshows. So there is one roadshow already planned in February in the UK. There will be another one organized in Toulouse, somewhere in France or something, in March, And there will be one organized in the US as well for the validation. In case you have issues, which should not be the case, but you can still send an email to the same email address to report to us any trouble. Now, this is how it looks like, but I will not spend too much time on this. I mean, the best is that you request an account, then you get access, and then you will see how it looks like. But basically, on this chart, you can see that you have the status of your documents. Then at the bottom, you have the list of your projects. Then you enter into one specific project, and you see all the documents related to it. Now, on the roadmap, so we have already released the version 1 since July. So the release 1 is on production. It's already available, and we have a number of projects you will see later. And it's if you wish, the basic functions of the platform. Now, we will extend the capabilities of the platform in the next 6 months by having more project management, LOI, and improved workflows. So the latest status we have is that there is 55 projects. Actually, I checked this morning and we are more 70 now. 70 projects, around 30 applicants using it. And we have a ramp up until the end of the year. Now, our target is first quarter next year to have all TCs, STCs, and major changes handled through the platform. All right, so this is it. If you have questions, I'm happy to take them, but the main message that I would like you to get from this presentation is that basically the platform is ready. If you are willing to use it, please send an email to your PCM. So if you have a given project, send an email to your PCM, I would like this project to be hosted on CPIAC. If he agrees, then send an email to cpiac-help to request the creation of an account, and then we will create this project for you. And then off you go, you can use it. Any question? After, okay.
Thank you, Olivier. It's perfect. We are now back on time. Question will be at the end of the session.
Okay.
And I'm now inviting on stage Guillaume Soudin and Anne Sénéchal, who will present successful harmonization with FAA in the field of software and airborne electronic hardware.
It's not the first line, yeah. It was the right one, but you were not on the first slide. Yeah, this is the one.
Yes, of course. Switch to the first slide, please.
Okay, no problem. Okay, thank you. Good afternoon, everyone, or almost good evening. So I am Guillaume Soudin, software senior expert at EASA, and my co-presenter is Anne Sénéchal, our EASA airborne electronic hardware senior expert. So we are going to talk to you about a very important project for the airborne software and the electronic hardware community, which is a project we worked on together with our FAA colleagues for the past 2 years. The harmonization of the software and the airborne electronic hardware policies. So we've worked namely with Barbara Lingberg, Dick Spencer, and Brenda Hawker from FAA, not forgetting actually John Strasburger, who worked for a while with us on this. So the presentation guideline and the structure of the presentation is quite simple. We will first talk about the context and the strategy that we chose. Then we will present briefly the resulting materials, so the software guidance, airborne electronic guidance, and open problem reporting management guidance, which are 3 separate AMCs and related ACs on the FAA side. And then we will talk about the benefits for your certification project, as well as the next steps. First, the context. So we, supported by a joint request from our industry, so both on the European and the US side, so ASD, IAA, GAMA, the 3 major industry associations. EASA and FAA have started a joint harmonization effort to revisit the software guidance. We are starting with something quite aligned but not fully, increment the AEH, so hardware guidance, and create a common OPR guidance for all 3 tasks with the goal of harmonizing the content of the guidance as far as practicable. On the EASA side, this activity has been done under a rulemaking task, the 643, which is our update of AMC 20 material. In terms of strategy, we have chosen a working group mode, which means we associated the industry associations during and along the development of this material. The drafting has been done by the EASA and the FAA teams, and then we organized working sessions along the process to gather industry inputs, feedback, and comments. And this allowed to reach for all 3 documents a good maturity before going to public consultation. And all of that has been done, of course, within a defined schedule. The very big novelty that we have managed to tackle in this working group mode is a joint public comment phase. So we have used concretely the EASA comments response tool to gather all the comments on both sides of the Atlantic from the full industry. And then we have processed those comments jointly on both sides, EASA and FAA, to avoid any misalignment until final publication. This is a brand new way of working. In the past, we had actually the potential for getting disaligned because we were managing comments gathered separately in a different manner. And now we have really successfully managed to result in a fully harmonized AMC and AC material. So that's really the highlight of this harmonization. Now I'm going to entering the technical parts of the slides. So we will not hammer to you too many technical details, but more we worked actually to give and provide the top level information you need to take away from even for, let's say, non-specialists. So on the software side, for the AMC 2115D and the AC, the associated AC, we started with identical software standards. Probably you all heard about ED12C and mostly about DO178C, which are common standards. The differences were lying more in the AC material that was calling for these standards, with several differences, mainly in the approach for using existing processes for new development, in the different conditions when modifying or using PDS, previously developed software, the differences in the guidance for TSO and ETSO, as well as a lack of guidance in the AMC, on the AMC side for tool qualification. One harmonization step we also used actually is to streamline the software guidance. We have created a one-stop shop AMC in order to embed all the necessary guidance for your projects. And this with the goal of avoiding raising crease on the software side when using this new material. The resulting material has been published for the software side on the 24th of October this year, so recently, a month ago. It results in one common document on the EASA side, so one AMC 2115D, which comes together with the GM, so guidance material to this AMC. On FAA side, it has resulted in two separate documents for the reason that FAA has no parallel, I would say, or mirror to this GM that we use on the EASA side. So we have found the best way to reflect this GM type of material, which was finally put in an AC00 series, which is best practices from FAA standpoint. But you have a fully harmonized material here. As said, the technical content is fully harmonized. We still have some editorial differences due to writing styles differences, but the technical part and content is fully harmonized. Here I try to extract the highlights for the software aspects, for the software AMC. So the section 5 now defines when existing DO178B processes can be used for new development. We were, actually, it's one of the big novelty. We were, I would say, not aligned at all in the past. FAA had some practices, we had some different ones in our AMC material. And now we are fully aligned with specific conditions to get there. We have clarified also the guidance for field-loadable software and user-modifiable software in section 8. This is originating from EASA certification memo and FAA order material. We have streamlined this material down to the software developers part. And the section 9 harmonizes conditions for reuse of software. Section 10 harmonizes the guidance on tool qualification. And the big point also as a takeaway, we have also worked on streamlining some conditions on reuse of newer technologies, if I can call it like that. So for both section 5 and section 9, for new development and for reuse, we have clarified that parameter data items, so configuration files, when using configuration files in a project, doesn't trigger directly a transition to D178C. And the same for all the three supplementary guidance, model-based development, object-oriented techniques, and formal method, which are supplements to the standard D178C. You don't need to transition to D178C for your full process if you used successfully an approved way of certifying these techniques acceptable from EASA standpoint. So that's for the software. Now we are going on the hardware side.
So on the airborne electronic hardware side, we have here the task which is AMC 2152. We named it A because FAA has already an AC 2152, and as we are harmonizing, we will go directly from an EASA standpoint to the A revision to show the harmonization on both sides of the Atlantic. So where we started, our context, we had also an industry standard, DO254 ED80. It was published in year 2000. It looks like 17 years ago. It looks like old, but it's not so old. It contains good fundamentals. It's fundamental to be used in airborne electronic hardware development. But there were new challenges, new technology, new items that were not enough covered or not covered at all. And they were supplemented by EASA certification memo and by the FAA order 81 and 10.105. Those two materials were different, but also with certain topics. So the EASA cert memo was describing activities, so it was sound for some industry as prescriptive. On the FAA order side, it's more intended for FAA personnel, so it's not directly to be used by applicant, even though it was actually used. So we did a work, and together with John Strasburger, we took some time. It took us about 1 year, John, to convince our both teams, our both organization, to have a joint effort and typically to have a joint list and agreed with industry a list of topics. So we took the standards and we looked at where are the safety risks, we looked at the existing guidance, is it sufficient or not, and we highlighted for the safety risk topic, we highlighted them into a terms of reference document that was defining our scope, and we kept that terms of reference along all the work. This was synced with industry and with good interaction with ASD, AIA, Gamma to establish a common list. Then the chosen approach. So how to change a picture that was not pleasing everybody. It was very important to come back to the key points, the safety aspects, and to have what we called a streamlined guidance. So that streamlined guidance needed to be objective-oriented wording instead of activities, going back to objectives. What are the objectives that the applicant should follow? So we focus first on what to achieve and not how to do it. And therefore, we would allow industry to have some flexibility to define how to do it in their plans. We use the approach, and that was very useful, to speak about SMART objectives. So SMART, we need to be specific enough. We don't go to the high level in the clouds of the sky, but we stay on the hardware, airborne electronic hardware domain, specific enough, but at an objective wording level, so that we have a measurable situation, achievable, realistic, and normally in the SMART methodology, it's time-scaled, but in an authority, we renamed it to tangible. We used as an approach to work in a small working group with industry, FAA, and EASA representative, and John was with me until April on that. And we both with industry worked with a small group, 15 participants only, EU and US industry. The topic was, we had a large challenge to fulfill, so it was important to keep it in a small but representative group. We had less than a year to do it, so we had intensive discussion with industry, and at the end, we estimate that those intensive discussions were very constructive, even though in some meetings we were, I see Jonathan smiling, we were not so happy at the end of the day, but okay, we managed. And both, we did really achieve consensus. Now going into a bit more details, I don't intend to make of you an electronic designer, don't be scared, we will not go in the details, but I will focus on what is covered in the guidance. So in the guidance we speak of there is three main topics. So the first one is this one, is a custom devices. So you have names for electronic designer, it tells something. So FPGA, PLD, ASIC. So it's designed, developed by the applicant and by suppliers. So for those ones, we can apply, and we suggest to apply DO254 ED80. And we have supplemented in the guidance ED80 for the gaps of technology that is not covered, and we supplemented it with key objectives. Those key objectives are related to requirements, the area of design, design review, and also the verification, robustness in verification, and code coverage. And this is to avoid issues at the end of some bugs not covered. We make a differentiation in hardware between simple electronic hardware and complex electronic hardware, and there will be differences in the objectives for the two sides. So we define a classification. So at the end, for this section, for this chapter, it's a clarification to D0254 for certain aspects. Next topic that we talked about is use of COTS devices. So COTS means a commercial off-the-shelf device. It comes out from the semiconductor industry. It's fully developed by semiconductor industry, and they have some structured processes to make it, and we take into account those quality processes to do it. So there, we will more focus on the usage aspects. So even though it comes out of a very structured process, they still have issues, or there is giant semiconductor devices to be managed, to be controlled, configured. Therefore, we need a bit of a process layer from the user perspective. And this is the topic that is of interest here on the use of COTS device. I have put some item as an highlight of the topic. I don't want to elaborate on those, but it gives to the people who are more in the topic to see a bit the area we investigated, and there are more than this in the paper. So the big move here is use of COTS is addressed with objective-oriented wording. The last big chapter is in between the two. So I just presented custom devices developed fully by the applicant, and you have COTS devices developed fully by semiconductor industry. And you have this kind of animal, use of COTS IP, which is a piece of hardware that can be used, that is done by certain designing company that sell an IP. But the IP here, the challenge is that the IP is not completed, its design is not finished, it's to be integrated into an electronic device. And those IP comes with different quality level. You can have software on some code on internet. It's hardware, but it's some code that is available on internet, or you can have a very structured IP company like ARM processors or Intel processors or whatever. So this is the challenge of the topic, is to address and establish a guidance for this wild and very wide area. So here we did a step in between. So we are using some aspects of some credit from the IP provider when there is credit, and to see what are the integration steps to be implemented in the device. So this was a quite difficult and challenging topic over all of them, because it was novel guidance. We didn't have anything on FAA side, like on EASA side we had a very small chapter of 8 lines. But so we moved further and established a guidance, and we are quite happy about the result and the interaction with industry.
Thank you, Anne. So now just 2 brief slides about the AMC 20 OPR, which will get a specific number very soon. So OPR, like Open Problem Reports Management, this guidance was not harmonized so far on both sides of the Atlantic, and this new AMC will provide guidance addressing simultaneously the 3 domains that are concerned, meaning systems, software, and AEH. So far we had software and AEH guidance. Systems guidance was more in the review process of OPR. We have really took the reference material from these 3 domains in terms of development assurance, and we have revisited all of that in order to create a standalone document not implying the use of any of these standards. So we will have really a standalone guidance covering the 3 domains simultaneously. We had some supporting inputs to name D0248C discussion paper 9, which contained extensive guidance for software sides, which was, I would say, a good starting point. And we used the lessons learned from certification projects, both on the side of industry, but also internally to our EASA and FAA world, let's say, where we had some brainstorming with all the actors that are participating to the assessment of open problem reports. We had also received a gamma report with some recommendations that we, in 2015, that we used. So it's a lot more than that, but I really focused here on this slide on the three essential aspects. So first, the definition. What is an open problem report? It's a problem report that remains open at the time of approval. So it's really at the time of approval that we make an OPR management. Nevertheless, the guidance has been focused in around two main sections, section 5 and 6. The section 5 address PR management, so problem report management, as a prerequisite for a good open problem report management. So what we want here is to provide minimal guidance to make sure first that the PR management is in place, and secondly that it is used efficiently along or throughout the development to make sure that we don't enter into a nightmare at the time of OPR management. And then we jump to section 6, which is the biggest part of the guidance regarding OPR, so open problem report management guidance. We have in that part revisited the classification scheme that you probably, some of you already know. This typology has been completely revisited to remove, I would say, ambiguities and aspects of overlapping between several classes of OPRs. We have also provided guidance on the assessment of the OPRs and the expectations regarding disposition for unmitigated safety open problem reports. The OPR reporting aspect is also developed, so this is something you will see very soon in a public comment phase. So, Anne, please.
So to conclude about this efforts of EASA and FAA harmonization, and we would like to give some feedback. So the first point is the effect of the current guidance. So we mentioned to you we had already AMC 2115C published. Now it's AMC 2115D, which replace the C revision, of course, and with application date, which is immediate after the 24th of October. The existing software certification memo is cancelled by this publication, remains available on the EASA website. It will be the same story for the EASA hardware, airborne electronic hardware certification memo. Now going on the other effect on projects, so we aim and we achieve the goal to reduce the number of software and airborne electronic hardware CRE by having a guidance that is published through an AMC, and it's valid for the hardware, it's valid also for the OPR, which had no guidance as an AMC. For software we had already, but we have additions as Guillaume presented. So in terms of CRE, we only have today a multi-core processor CRE, which is an addition when an applicant wants to use a multi-core processor with more than 2 cores activated. So there is another benefit that we have, it's about validation projects. So the big effort of harmonizing with FAA really makes sense to rationalize our effort in validation. If we have the same guidance, the same applicable reference, then we ease the certification project, and the compliance demonstration is already established by through the primary authority. So we think that both AMC ACs will reduce the certification difference during validation activity. We still see some difference to be expected at installation level when we have ETSO. So the AMC on the EASA side will be applicable immediately when we will update the CSE TSO. So AMC 2115 is already applicable. For the 2, it will be in CSE TSO update, and they will be applicable. But for the FAA side, it's a bit different because it's a new template of TSO that will be updated. It will refer to the AC material, so it is ongoing for future, but for the past TSO that are published, we will have some gap to be addressed at installation level. So what's next to come? AMC 2115D is published, so for that aspect, it's over. For the hardware and the OPR, we have finalized the final draft, and we should publish very soon We will have a joint public consultation in beginning 2018 together with FAA, and we will have a final publication after a joint disposition of comment together with FAA to achieve a common material at the end. And that concludes our presentation.
Thank you, Guillaume. Thank you, Anne. We will take now questions for the panelists.
Yes, Robert Grove with Garmin. This question is for Anne. Prior to this harmonization effort, a significant disconnect between the FAA and EASA was with the application of DO-254, where the FAA did not require DO-254 to be applied when there were no custom logic devices in a product. And then since the revision of the TIP, where TSOs are mutually accepted, an issue has arisen where products that have TSOA have then no custom logic devices have been required by EASA to have DO-254 lifecycle data at the installation level. Now, is this disconnect something that has been addressed that in the new harmonized AMC?
Yes, of course, because the AMC will be applicable to across the different CSs. So your problem was at installation level. So when you were meeting expectation for requirement of the CS, and therefore was requested at that level. But this will disappear. But there will be still some activity at installation level of TSO, such as you see today, we have the use of COTS device, which is additional, the use of COTS IP. So if this has not been addressed during the TSO, it will be questioned at the installation level. And therefore, we want to have a common guidance between TSO and aircraft level, which is the way we are going, FAA and EASA.
So EASA will continue to require additional documents not required by the FAA for the design approval of products, as particularly legacy products.
It is the same situation for FAA. No, it will be the same AMC AC. So FAA would have the same type of question for ETSO. FAA has the same AC, so it will, the reference is the AC, a new AMC. It will be that.
For new products, that's not a problem. Where it is a real issue is for legacy products where the TSO has already been granted. And that TSO is accepted under the bilateral for design approval.
So I cannot disclose all the content of it, but I don't expect much issue there because we have moved further into the guidance. We focus only on very complex codes. The limit is very higher. And on COTS IP, we didn't have much usage in the past. It's coming now. It's novel, more novel. So I don't think, let's see when the guidance is published if you have a problem there.
Any other question? Yes, I see one on the back.
Hi, this is for John. This is Alex Merles, EASA. John, artificial intelligence, as you know, it's out there since 20, 30 years. Are you looking into the group, the machine learning algorithms, also to control highly critical functions? Let's say FADEC or something similar.
Right now, I'm looking at anything that's automating stuff that happens in the cockpit with the use of machine learning. If you know of instances where machine learning has been used in the past, I'd be interested to talk to you and how you've handled that. I'm not aware of any. I do know that some microprocessors now have some machine learning capacity for handling the power internally, but I'm not aware of any machine learning applications myself right now.
Hello, this question is for Anne again. My name is Nicofalis. I'm with Sikorsky Aircraft. The question is twofold. There was, on your last slide regarding DO-254 compliance, a comment there that if we still certify something under FAA, under a TSO with DO-254 compliance, there may be additional crews because of this disconnect. It wasn't very clearly stated there. So if we do certify right now something under DO-254 with the FAA, the bilateral will be acknowledged on the EASA side without any additional crews?
The bilateral and mutual acceptance, reciprocal acceptance, to quote well, is in the tip, and it will be, and it stays. So it doesn't interfere with that at all. What we were talking about is, so when you develop a custom device, if you apply DO-254 at FAA side, you will see at FAA side that if you use some novel technology, which is addressed in the new AC 2152A, you will have that to follow. So there will be, if we move the rules all together, we are aligning, and we are in fact helping for sure the reciprocal acceptance, but even more the installation level. So there will be no addition between the two worlds, between the two AMC AC. What Robert was talking is about things in the past of something that has been developed according to certain aspects and is today going for certification at aircraft level. But let's see when the material is published. We go in a direction to address more novel technology, novel usage. Like COTS IP was not much used. We didn't have usage of that. And the COTS processors that were used 7 years ago, they don't look like the COTS processor of today. So it's the bar, as I said, the bar is higher. But of course, we cannot disclose the thing. It will be published. There will be an NPA. You will have opportunity to comment. But we invite you to see. But both authorities will have the same.
So what you're saying, in other words, that if during the, and this kind of goes back to John now because it's an FAA question really, is if during the public commenting period there's alterations to the AC based on comments, then we would probably have to revisit this issue again with EASA then.
I think the whole idea with the public comment period is that we will work with the EASA to come up with an agreed to response to the comments. At least that's my understanding when I was still involved in it. So I think what will happen is will still be harmonized. I think the whole idea behind that is when we get done with AC 20-152 after the public commenting period, that we will have harmonized guidance.
Thank you.
Just to complement this answer, I think what we present here is the guidance. So at the guidance level, the intent, and so far we managed, and we did for software, is to have a fully harmonized thing. So for any new product, there will be no difference at all. What we stated on this slide regarding TSO and ETSO is more addressing something that is outside of the scope of what we could do in revisiting the guidance. It's about the differences we may have still in our systems, TSO, ETSO. In the ETSO side, that's what is written. We have the CS ETSO subpart A calling actually the new guidance directly. For the TSO world, as far as we know so far, you have the guidance actually related is directly called by the TSO order itself. And that's what we wanted to highlight. It's something that is really going beyond what we could do here. But the good news is for new products, no difference. That's the point.
And we are working with FAA on TSO side to see what we can do to upgrade. Because you have TSO standards that are old like 1970. It exists. So if the applicant doesn't elect to comply to DO-178 or DO-254, we cannot really play the same game.
Should we take a question online now? First one is on EASA. After the recognized effort on software and electronic urban hardware harmonization, when is a comparable effort on TC level envisaged for foreign validation, safety emphasis item according to the TIP revision 6?
So, I guess I will answer this question. A lot of effort has been done in the software and urban electronic hardware side to harmonize. We will actually first identify the SOI items, which are not very easy today. It's under the radar, I would say. So the first step is identifying them, and this is a must before the TIP 6 enter into force in March next year. That's something both EASA and FAA are committed to make. The second step will be obviously to converge on these items and as far as possible streamline validation efforts and enhance mutual recognitions of TC and, in the system. But you know, it's in the frame of the EASA FAA validation roadmap. Hopefully some other authorities are also joining at some point in time. But that's, in fine, I would say, the roadmap 2022 that has been presented to industry concept.
So for the next two questions, it's on Olivier Tribou. On CEPIAC, first one is related to the black box. So if a document gets stuck in a system, do we have visibility on seeing where it's stuck? And the next question is related to the compliance checklist, including means of compliance, if we can take that in the tool.
All right. Well, thank you very much first for asking questions to me. So the first one on internal workflow, yes. So this is the principle of CEPIAC, is that like everything is visible. So yes, you see that one of your documents have been like submitted, and that it is pending EASA review. So the answer is yes, you can see it. And the second question, I'm not completely sure to understand what you mean. So on CEPIAC, you can upload any document. So yes, you will upload like the CCL, and CCL will be reviewed by our experts, and then after that, you can upload your compliance documents, and they will be reviewed as well by EASA. I'm not sure to understand the question if by managing the CCL, you mean like entering the CCL live in the system. But if it's the question, then no. The answer is no. For the time being, it's only documents. So you just upload your CCL on the system, then we will review it.
Thank you. Next question is, does EASA intend to provide guidance on software and urban electronic hardware acceptance qualification of EATS equipment for installers?
So if I well understand, the request is to have an ETSO software or an ETSO hardware. We are not intending to have that. We have ETSO with a functional ETSO. So it's we have a list, a big list of functional ETSO with an aircraft function to be certified. The next domain we went to is to have an IMA ETSO 20153, and we go further. Even we had an NPA with an intermediate IMA, which is more a process ETSO in terms of using an IMA platform. And going for an ETSO certification, not redemonstrating the IMA platform performance, but we don't go for an ETSO software. It's an ETSO as an aircraft function, typically.
Okay, and I will take the last one, the 178, regarding lack of definition of robustness testing in the 178C. Actually, there is no plan to address this topic anymore because we've closed the AMC 2115D together with FAA, so the plan is not there. However, on this topic, I would just say that the 178 is not a detailed guidance. I mean, you have some requirements for robustness testing. This is something that is then discussed at project level with each applicant and each supplier with their processes. So this is really not something on which we wanted to go in more details, because we didn't want to go for prescriptive guidance, but actually more to remove and have some more objective oriented guidance all over.
So thank you, Guillaume. I think you can take the next one.
I think it's for you want to respond?
Oh, yeah, it's for FAA.
Where's the last one? Oh, okay. Oh, okay. Unfortunately, I'm not working. I'm not working that.
So, sorry, John. I saw FAA, so I thought you wanted to answer. No, yes, definitely. We will harmonize AMC OPR with the AC OPR, and we completely want with that to remove any special condition IPs crease related to that guidance. So it's clear. Yeah. Thank you.
Thank you very much. I think we are at the end of the first day of this Rotorcraft Symposium. I would like to thank you all for attending that. Just as a wrap-up, we went through this morning our executive director speech, who gave a bit of outlook on EASA and especially the new basic regulations that may change quite a lot in the future, especially, you know, the rotorcraft industry. We may have under EASA umbrella the future Annex 2 or the current Annex 2 aircraft, but also some military aircraft. And you know, rotorcraft is very well, the rotorcraft industry is probably the best place to have all this coming up, because most of the aircraft are dual use. So it's very exciting moment that we are looking forward to it. He also mentioned that rotorcraft, looking back at the statistics and safety record, will be EASA priority in the future. So we'll really rebound on that. At the end of the day, also we've seen that EASA and regulator are only one element of the safety, not continuum, sorry, but the safety landscape around rotorcraft. It must be an effort from all stakeholders, and that's really from the design to the operations, but also maintenance and general airworthiness. For that, there are some initiatives. The FAA has taken the safety continuum aspect. We have also some harmonization on the software and electronic hardware. But at the end of the day, it's about safety, culture, and just culture that we need to really promote in the rotorcraft industry. And that's what Heli Offshore called the cultural revolution among rotorcraft. That's something I think we need to take on. And actually, it's the right time for the rotorcraft industry. The industry is changing. New players are coming in. The safety issues are now on the horizon. It's not anymore under the radar. If you see now accident, even in rotorcraft, they are now in the news in specific operations, but they are there. And it's really something we need to take into account. We have also to tackle the general aviation and the lower end of the aircraft or the rotorcraft that are flying today. So it's really something that planets are aligning all across the industry to move forward. And that's really something we are looking forward as EASA. One of the key elements will be sharing information all together from everybody. Obviously, some initiative like Heli Offshore has taken in the offshore industry could be replicated elsewhere, and we are committed at EASA to promote that, and launching data for safety, for instance, will be hopefully a key enabler to have a better risk identification among industry, and then enable us to take the corrective actions that could be, or stress the positive ones. You know, that's the two sides of the coin. We need to promote the best practices, but also address some corrective actions. At the end of the day, also, we are tackling the future. We have innovations coming through, new player coming, design that are evolving also. We have the innovation also in the regulatory framework, in software, hardware, artificial intelligence, machine learning. That's very exciting to see that. And by the way, it's coming sooner than what we expect. And some players are already very much ahead of that. We mentioned automotive industry, but some also aviation industry, which are not legacy, are coming up with very innovative ideas and way of thinking. And by the way, they are going much, much, much quicker than the traditional aviation industry. So that's something we must take into account. So as I said, for me, and I hope that you realize that, we are at crossing roads in the rotorcraft area, and I hope we will take all together the right path towards safety and promoting this industry. For that, we need investment, obviously, but we need also to commit resources associated to that, invest in research. EASA is really committed to do so, and to promote any initiative towards safety. And at the end of the day, we would like to provide a better visibility on what EASA actions will look like in the future, so that at the industry level, you can better forecast your investment, where it's worth going in, and working together will be the key for the future. So I would like to thank you again for your day. It's a long day, and I hope you enjoyed it, as I did. And I would welcome you back tomorrow at 8:30 for the registration, starting at 9. In the meantime, we have the dinner, I guess, or sometimes you can relax a bit and then enjoy dinner and take the opportunity to meet people from all across the rotorcraft industry. Thank you very much, and have a nice evening.